Hello everyone, welcome to Abstract Algebra Group Theory classes. Today we shall study binary operation group, Abelian group as well as non-Abelian group. So first of all, we shall study this binary operation. Binary operation, let this G be a non-empty set and A, B, C are its elements. Then A star B also belongs to this G. Then star is called as binary operation on G. It means when this A star B is also an element of G, then this star is a binary operation on set G. Take so means let G be a non-empty set phi and A and B, A and B be its elements. Then, then A star B must be belong to G. Then star is then this star is a binary operation on G is a binary operation on G on set G. ठीक? Means A star B is also an element of set G. Then star is a binary operation on. This is the binary operation. It can be addition, it can be multiplication, it can be subtraction, and finally it can be division. So we shall study its first two, this mathematical operations. Number one, under addition. If A plus B belongs to G, for every A, B belongs to G, A, B are the elements of G, then G is closed under, then G is closed, closed under binary operation plus. See? Secondly, in the case of multiplication, if A multiplied by B, this element also belongs to set G. For every A, B belongs to G, then then G is closed, G is closed under binary operation multiplication. So second group is let G be a non-empty set occurred with the binary operation star, then G star is said to be a group if it satisfies the four axioms. First axiom is closure axiom, second is associative axiom, third is identity axiom, and fourth is inverse axiom. In this group, let this G be a non-empty set phi and elements A, B and C belongs to G. Then this algebraic structure G star is said to be a group. Is said to be a group. Is said to be a group. If G satisfies G satisfies four axioms. Satisfies four axioms. Number one axiom is closure axiom. Closure axiom, or you can say closure property. In closure axiom, let this A B belong to set G, then A star be also an element of G. क्या आ गया? If A B belongs to G, then A star B must belongs to G. क्या इसका मीनिंग आ गया? अगर ए बी जी के दो एलिमेंट है तब हमारे पास ए स्टार बी बी जी का ही एलिमेंट होना चाहिए. इफ दिस कंडीशन इज सेटिस्फाइड, इट मींस जी satisfies G satisfies closure axiom. Closure axiom under star, under the operation star. एक आ गया. And this operation star may be addition, it may be multiplication. Means this operation star may be addition and it may be multiplication. Number one, under addition. If AB belong to G, then this A plus B must belong to G. It means G satisfies closure axiom under addition. It means, which implies G satisfies closure axiom under addition. ठीक. सेकंड पार्ट है इसमें, if this star is a multiplication operation, star is a multiplication, then A cross B must belongs to G. It means then this G set G satisfies set G satisfies closure axiom under operation multiplication. ठीक। उसके बाद है इसका सेकंड एक्सिम, नंबर सेकंड एक्सिम इज एसोसिएटिव एक्सिम। एसोसिएटिव एक्सिम, इसमें हमने क्या बताना है कि इफ दिस ए बी एंड सी आर द थ्री एलिमेंट्स ग्रुप जी, then a star of b star c must be equal to a star b of star c. This is called as associative axiom. If a b c, if element a b c belong to set g, then then a star b star of c must be equal to a star of, then this implies that G satisfies associative axiom. Associative axiom under star, under operation star. ठीक, and this operation star may be addition as well as multiplication. In the case of addition, number one, in the case of addition, this a plus b plus c is equal to a of plus b plus c. If these both are equal, it means this G satisfies associative axiom. Associative. Second is under multiplication axiom. If this a star b star c is equal to a star b star c, then this G, अब ये दोनों equal है, then G satisfies associative axiom. Associative axiom. The third axiom is identity axiom. Identity axiom. A element A belong to G, then there exists element E also belong to G. अगर A G का एलिमेंट है तो E भी G का एलिमेंट है, such that A star E is equal to A is equal to E star E. So here E is the identity element in G, which implies E is the identity element in G. Element in set G means इस आइडेंटिटी एलिमेंट को एलिमेंट ए में हम अगर ऐड करते हैं या मल्टीप्लाई करते हैं, इट डज नॉट चेंज द वैल्यू ऑफ एलिमेंट ए, सो इज द आइडेंटिटी एलिमेंट ऑफ ए। अब इसमें है when this star is addition or multiplication. Under addition, this A plus identity element E is equal to A is equal to E plus element A for every A belong to G. ठीक, अब A में कौन सा एलिमेंट ऐड करें कि फिर से हमारी वैल्यू A ही आ जाए, तो दैट इज 0. तो इट मींस E is equal to 0 is the identity element in addition. Identity element in addition. ठीक, सेकंड पार्ट है इसका, when the binary operation is multiplication, then A into E must be equal to A, and this is equal to E into A for every A belong to G. Means E एक ऐसा एलिमेंट है जिस नंबर A को अगर हम उससे मल्टीप्लाई करें तो फिर से वही नंबर आ जाए, तो वो नंबर कौन सा आएगा, दैट इज 1. तो जे आएगा E इज इक्वल टू 1 is the identity element in case of multiplication. ठीक, तो once we revise it again, in binary operation means हमारे पास नॉन एम्प्टी सेट G है और A B C E इसके एलिमेंट्स हैं. When this A star B is also an element of G, then star is a binary operation on G. ठीक, क्या आ गया, let G be a non-empty set and A B C are the elements. G be a non-empty set and A B C are the elements of this set G, then A star B must belong to G. A star B जो है वो भी इसका एलिमेंट बनता है, then star is a binary operation on G. ठीक, and this binary operation star may be addition, multiplication, subtraction as well as division. If in the case of addition, if A plus B belongs to set G, for every A B belong to G, then G is closed under addition. मतलब A और B हम दोनों को ऐड करने पर, जैसे जी हमारे पास एक सेट है, नॉन एम्प्टी सेट है नेचुरल नंबर का, तो नेचुरल नंबर्स होते हैं 1 2 3 अप टू इंफिनिटी, यही है ना. अब इसमें क्या है कि जे आ गया एलिमेंट, ए आ गया 1, बी आ गया 2, तो अब ये हमारे पास है a plus b must be belong to n. It means 1 plus 2, तो क्या आएगा 3 and 3 also belong to n. So it means this set of natural number is closed under addition. Second part है, if a cross b belong to G, then G is closed under multiplication. ऐसे ही A क्रॉस B must be belong to say n. तो A हमारे पास 1 है, तो B की वैल्यू आ गई 2 and this is equal to 2 and 2 also belong to n. So this n is closed under ऑपरेशन मल्टीप्लिकेशन। ठीक, तो नेक्स्ट है ग्रुप। व्हाट इज ए ग्रुप? तो ग्रुप इसमें दिया गया लेट जी बी ए नॉन एम्प्टी सेट and A, B, C, E are its elements, and then this G cubed with binary operation star is called as a group if it satisfies the four axioms. Number one is closure axiom. If A B belong to G, then A star B must be belong to G. अगर A B G के दो एलिमेंट हैं तब A star B जो इसका रिजल्ट आएगा that also belong to set G. Then we can say G satisfies the closure axiom under star. ये आ गया इसका जर्नल। अब इसमें है कि this star can be addition and it can be multiplication. So in the case of addition, A plus B belong to G for every AB belong to G. So it means G satisfies the closure axiom under addition. अब ये देखिए नेचुरल नंबर्स है हमारे पास, ये अगर 1 2 3 अप टू इंफिनिटी, तो इसमें जाएगा a प्लस बी, ए आ गया 1, बी आ गया 2, 1 plus 2 is equal to 3 and 3 also belongs to natural number. So it satisfies the closure axiom under if a b a cross b belong to G for every a b belong to G. A क्रॉस B मीन्स A हमारे पास है एलिमेंट से 2 है, B आ गया ये 3 है, देन A क्रॉस B is equal to 2 cross 3 and this is 6 and 6 also belong to natural number. So this G मतलब this set N satisfies the closure axiom under closure axiom under multiplication. ठीक, अब इसके बाद है सेकंड axiom that is associative axiom. इसमें हमने क्या बताया है कि G एक हमारा नॉन एम्प्टी सेट है, ABC आर इट्स एलिमेंट्स, then A star of B star C must be equal to A star B of star C. Then it satisfies the associative axiom. If A, B, C are the elements of set G, then A star B of star C is equal to A star of B star C. अगर दोनों की वैल्यू सेम है, then it means set G satisfies the associative axiom under star. तो जैसे पहले बताया है कि this star can be addition or multiplication. In the case of addition, if A plus B plus C is equal to A plus of B plus C, then this G satisfies the associative axiom. Means जैसे J हमारे पास है नेचुरल नंबर का सेट है 1 plus 2 plus 3 is equal to 1 plus 2 plus 3 for every 1 2 3 belong to natural number n. इन दोनों केसेस में ब्रैकेट चाहे पहले हो या बाद में हो, the sum is 6 and 6 also belong to natural number. So this natural number n satisfies the associative axiom under addition. ठीक, यह क्या अंडर multiplication. If A cross B cross of cross C is equal to A cross of B cross C for every ABC belong to G, then G satisfies the associative axiom under multiplication. इसमें क्या है, हमारे पास A बराबर 2 है, B की वैल्यू है 3 एंड C is 1. Then A cross B cross C must be equal to A cross B क्रॉस सी. तो ए है 2 क्रॉस बी आ गया 3 क्रॉस 1 इजिकल टू ए आ गया 2 क्रॉस 3 क्रॉस 1. तो दोनों केसेस में रिजल्ट इज 6 and 6 also belong to natural number n. So it satisfies the this natural number n satisfies the associative axiom under multiplication. ठीक, if A belong to set A, then there exists element E also belong to the same set G such that A star E is equal to A into E star A. So here value of A does not changes. So it means E is the identity element in G, and this star may be positive addition or multiplication. In case of addition, A plus E must be equal to A. कौन सा ऐसा नंबर है कि A में उसको हम ऐड करें तो फिर से हमारी सेम वैल्यू आ जाए. जैसे ये हमारे पास नंबर 2 है, इसमें कौन सा नंबर ऐड करें तो फिर से हमारे पास 2 ही आ जाए, तो दैट नंबर इज 0. तो इट मींस E is equal to 0 is the identity element in addition. In the same way, in case of multiplication, E multiplied by E is equal to A is equal to E into A. मीन्स A को हम किस नंबर से मल्टीप्लाई करें कि सेम नंबर दोबारा. जैसे ये हमारे पास है 3 मल्टीप्लाइड बाई व्हाट number and 3 comes again, that is 1. So it means in the case of multiplication, E is to 1 is the identity element. तो जो fourth axiom है, if A is an element of G, then there exists element A inverse also belong to set G such that A into A inverse is equal to identity element E. ठीक, if A is an element of set G, then there exists element A inverse also belong to set G such that A into A binary relation A inverse is equal to E is equal to A inverse into A. Means then G satisfies the then this G satisfies the, अगर ये इसके इक्वल है, then G satisfies the inverse axiom, satisfies the inverse axiom under star, with respect to star under binary relation star, and this binary relation star may be positive or it may be multiplication. So in case of addition, uh, A plus A inverse must be equal to identity element E is equal to A inverse plus A. If this condition is satisfied, so it means G satisfies the, it means set G satisfies the inverse inverse axiom with respect to multiplication, with respect to addition. And in case of multiplication, if A multiplied by A inverse is equal to E, identity element E, and this is equal to A inverse into A, then this G satisfies the inverse axiom under multiplication. Then this set G satisfies the inverse axiom inverse axiom with respect to multiplication, with respect to multiplication. Okay. If these four axioms are satisfied, then this set G acute with binary operation star is a group, is a group. अब इसके बाद है हमारे पास ग्रुप के बाद है अबिलियन और नॉन अबिलियन ग्रुप्स. अब इसमें these are the four axioms to be a set equipped with binary operation to be a group. When one more property is also added in these four axioms, so that fifth axiom is commutative axiom. If commutative axiom is also satisfied, then the given set will be a abelian group. Means commutative axiom are A, B, A, B are the two elements of set G. Means A, B are the two elements of this set G. Then A star B must be equal to B star A. If this condition is satisfied, it means G satisfies commutative axiom under star. If A, B belong to G, then A star B must be equal to B star A. Then G satisfies the, it means G satisfies the commutative axiom under star with respect to star operation star. And this star may be addition and it may be multiplication. In case of addition, in case of addition, A plus B must be equal to B plus A for every A, B belong to G. It means G satisfies the, it means G satisfies the commutative axiom, commutative axiom under with respect to addition. In the same way, in the case of multiplication, A cross B must be equal to B cross A. It means this set G satisfies the commutative axiom, commutative axiom with respect to multiplication. When these five properties are satisfied, then the given set G under operation star is a is a is an Abelian group. If this fifth property is not satisfied, so this set G is not an Abelian group. It is called as non-Abelian group. Non-Abelian group. If, so once again, inverse axiom. If A is an element of G, A जो है G का element है, then there exists another element A inverse, which is also the element of G, such that A star A inverse is equal to E is equal to A inverse star A. Means A into A inverse का जो multiply है, that is equal to identity element E आता है, then it satisfies the inverse axiom. And this operation star may be addition and it may be multiplication. In case of addition, A plus inverse of A is equal to 0, is equal to E, and that is equal to A इनवर्स प्लस से मीन्स हमारे पास एलिमेंट है 2 और 2 का एडिटिव इनवर्स जो क्या आएगा -2 एंड इट इज इक्वल टू, इट मींस 0 is the identity element, identity element in addition. मतलब कौन सा नंबर है कि उसको हम उसी नंबर में ऐड करें तो फिर से हमारे पास वो आइडेंटिटी एलिमेंट बनता है, दैट इज 0. तो सेकंड आ गया मल्टीप्लिकेशन, ए क्रॉस ए इनवर्स मस्ट बी इक्वल टू ई. हमारे पास एक नंबर है 2 से और 2 का इनवर्स ये क्या होता है 1/2 एंड दिस इज इक्वल टू 1, तो 1 इज इक्वल टू ई. तो E is equal to 1 is the multiplicative inverse. ये क्या आएगा, दिस इज द मल्टीप्लिकेटिव इनवर्स. तो फाइनल commutative axiom in this, or you can say it is called as Abelian axiom. If A, B are the two elements belong to set G, then A star B must be equal to B star A. If this axiom is satisfied, the given set G under star is called as an Abelian group. If this A star B is not equal to B star A, then given group G under operation star is non-abelian, then it is a non-abelian group.